Hey guys, how's everything going? I hope you are doing well. Today let's take a look at number 92, reverse linked list 2. I think I'm not sure whether we've done the easy one, reverting linked list. Easy 200. Oh, 200. So we haven't been there yet. Okay, we are required to reverse a linked list from position m to n. Do it in one pass. Okay. For example, we input 1, 2, 3, 4, 5 null. We need to reverse the part of the links from 2 to 5 to 4. So 2 to 4, 2, 3, 4, reverse it, 2, 4, 3, 2, 5. It's kind of not that difficult. So let's analyze the example. 1, 2, 3, 4, 5. We're going to reverse 2, 3, 4, right? Okay, so we need to find these two nodes, because we need to reverse them. We need to some operations which we need to do some manipulation. That's why we need to get to know the previous node as well. Okay, so we now know that where 1 is and 4 is, 3, 2 is. The goal is to transform to 1, 4, 3, 2, 5, right? Okay, so the node before 2 is 1, so we need to switch the nodes next to 1 from 2 to 4. How we do that? We can do it one by one, right? I mean, we know where 1 is, we know where 2 is, so we swap 2 and 3 first. 2, 1, 3, 2, 4, 5. Then we know where 1 is, and we swap 4 with it's not swap but insert, right? I think insert 5, 2, 1, 4, 3, 2, 5, and then we check 5. 5 is the next one of previous 4, so we're done. So the core idea become we find 1, find 2, find 5, and then insert 2's next into after 1 recursively, right? We find 1, we find 2, we find 5 until 5 is met. The next one of 2 is 3, so we insert it to 1. And then the next one is 4, insert to 1. And the next of 2 is 5, because it's 5, so we stop. Okay, so the problem becomes clear. We need to find these 2 pointers. So before we start, the n might be 1, so the node before 1, there's no node. So as usual, we better insert a false node as the false start to make things easier. So const start equals new list node 0, start next equals head. The input mn is supposed to be valid, so we don't need to care about the irregular cases. Now let p p before equals start. Let p is p pm, okay, pm equals head. Let p okay, pm start, pn equals start. Now there's another trick, is that we need to do it in one pass. We just use fast slow pointer. Let Pn to run a little faster, and then move them together until they met the target, right? What we want to do is that move Pn to 4, move Pm to 2. So this is m minus n. So while m, because they are 1 based, so if m equals 1, then it's from here. Okay, so because it's 1 based, so it's 1 for 1, it just moves to 1, so it's bigger than 0. M minus 1. Okay, if m is bigger than n, wait a minute. Okay, while m is bigger than n, we move Pm equals Pm's next, right? If m is 1, now Pm goes to the head, just to where it should be. Okay, and then while n is bigger than 0, n minus 1, Pm dot next. Oh, I made a mistake. This is n. Okay. Pn, and then while m is n equals Pn dot next, m minus 1. So for m1 and 2, actually Pm will end at 1 and Pn will end at 2. Okay, now P before, let's say let P after equals null. P after means P5, P before means P1, so P before needs to move also. Okay, P1M that is hard to do, so I'll change the PM to head, PN to head. Now this could be used, but this will be minus 1, be changed to 1. So while m is bigger than 1, we move, and P before equals P before next. We all move 1. If m is 2, 2, yeah. So everything's good now. Everything is good now. So P after equals Pn's next. So everything is done. This is done. Everything's done. Every pointer is set to the right position. Now we are do the recursion. The recursion is what we explained here. We keep inserting the next node of P2, which is Pm. Oh, P before the next node. Wait a minute. The P2. Oh yeah, the PM. inserting PMs next after P before. So while P M's the next is not P after, which is very clear, right? We will cut the next first, cut off P M's next, which means PM next equals PM next dot next, right? And P before next equals PM. PM next equals PM. Oh no, PM done. Wait a minute. Node equals PM next. PM next equals node next, which means 2 set to 4, and P and node next equals PM. 3 to set to 2, and P before next equals PM equals node. Yeah, and that's done. Now we will check PM again, and it will finally meet P after. And then finally we return the start dot next. Yeah. Hope it will pass. Of course not. This is wrong answer. Okay, we get 1, 4, 2, 5. 3 is missing. This must be something wrong with the boundaries again. Outlog the PM P before, PM PN P after. Okay, P before is 1. PM is 2. PN is 3. Something is wrong. P is not P3. Okay, because 4 is bigger than 2, so we move it to PN to 2. Now it becomes 3, right? Oh, my bad. 2, 3. 4, 2. If we check like this, it's actually only 2 nodes ahead, but actually there will be 3 because 1, 2, 3. Wait a minute. One pivot for each one, okay? PM is 2, okay? Okay, PM is 4, okay? It's 5, okay, there's no problem here. There's a problem here. PM is not after. We will cut off PM next. Node is PM next, is 3, 1, 4, okay. I'll say 1, 2, 3, 4, 5. We cut 3 off. 3 is next, not set to 2 is next, set to 4, right? And then node next set to PM, 3 set to 2, and then pivot 4 next set to node. So p before is 1, 1, 3, 2, 4, 5. 1, 3, 2, 4, 5. This is right. And now do it again. 4. 4 p.m. 2's next equals 5. Yeah, I made mistakes. Insert. We forgot to do insert. First we cut it off. Node equals pm's nest. Pm's net equals node. Okay, now node is off. Now insert. P should be pm next. Should be p before next. And then p before next equals node. Oh, node, my bad. Node. Oh, my bad. Still. I'm not very good at algorithm. Yay, we're accepted, so it's not that difficult. We've done it in one pass. Yes, there's two techniques used here. One is false start, and the next one is fast slow pointer, 2 pointers. Like let one pointer go ahead before the next node. So keep these 2 pointers always keep the distance constant. That help us to target the node we want. Okay, so this is it. Hope it helps. Yeah, see you next time. Bye bye.